Welcome to the first lecture on solution of triangles. Till the last lecture, we were discussing the properties of triangles in general. We also solved a lot of problems, but the focus of this particular lecture is going to be the following. So, basically all of us know that in a triangle there are 3 angles and 3 sides. Therefore, it is clear that given the value of the measure of these 3 angles and the length of the 3 sides, one can easily uniquely determine and probably construct the triangle. However, what would happen if suppose we give less information? So, let us say that we know the lengths A and B of a triangle ABC. The question now is, can we now uniquely determine the length C? So, the length A is basically the length of the side opposite to angle A, length B is the length of the side opposite to angle B. So, those two are known, and then the question is whether just by knowing them can we uniquely determine the remaining 4 parameters. So, the remaining 4 are basically the length C and the 3 angles of triangle ABC. So, that is the question. So, of course, even a high school student can see that we cannot uniquely determine the triangle ABC, because for this case even if we know, so let us say this is the side BC of length A. So, this is known to us, and then the only other thing which is known to us is the length of the side opposite to angle B, which is the side AC. So, we know the length of AC, but then so only the length is known. So, let us say this is equal to 4 centimeter. So, we can draw a 4 centimeter line here, and let us say we are given that B is equal to 6 centimeter. So, we only know these two things. Can we still uniquely determine the other third, the length of the third side of the triangle and the remaining 3 angles? The answer is no, because with A equal to 4 we can draw this straight line BC. Now, we are also given that the length of the side AC is 6 centimeter, but then 6 centimeter could be over here. So, we could have A here and this could be 6 centimeter. So, essentially if we draw a circle with center at C and let us say of so this will be slightly further because this is 4. So, I have taken it as 6. So, let us say if we draw a circle with center at C and radius equal to 6 centimeter, then the circle would be something like this, and we could take the vertex A of the triangle ABC to be any point on the circumference of this circle. So, for example, if we take this point as A, then we can join this with C, this would be of length 6 centimeter, and then we could join B with A. So, this is one possible triangle where A is 4 and B is 6 centimeter, but then we could have taken some other point also as A, for example here. So, even this is another valid triangle where A is equal to 4 and B is equal to 6. So, therefore, we see that this information is insufficient to uniquely determine the triangle ABC, because then we have infinitely many triangles possible. Similarly, one can show that out of this six elements of the triangle. So, the 6 elements of the triangle are, so in any triangle ABC, the 6 elements are the lengths of the 3 sides, so that is AB, BC, AC. So, we denote these by C, A and B, and the other 3 elements are the 3 angles A, B and C. So, it is not very difficult to show that if we are only given 2, or if we know only 2 out of these 6, then one cannot determine the triangle uniquely. So, then naturally the next question is, what if we know 3 elements out of these 6 elements? So, for example, if we know the lengths of the 3 sides. So, the first case is when all 3 sides are known. So, basically we have a triangle ABC where all these 3 lengths A, B and C are known, and but these 3 angles are unknown to us. So, now our task is to find the value of these 3 angles given the value of, or given these 3 lengths, and that is not very difficult because we know the cosine law. From the cosine law we know that cosine of angle A is B square plus C square minus A square by 2 BC. Cosine of angle B is A square plus C square minus B square by 2 AC, and cosine of angle C is B square plus A square minus C square upon 2 AB. Now, since A, B and C are all known given to us, we can find the value of the cosine of all the 3 angles. And if we now plot, if you remember the graph of the cosine function, so let us say this is x, we are plotting cosine of x, let us say this is x equal to 0 and this is x equal to pi, x equal to pi by 2, 1 and minus 1. Now, because all these 3 angles are restricted to the interval 0 to pi, let us draw the graph of the cosine function with x restricted to 0 to pi, and the graph is like this. We see that the graph is monotonically decreasing, and therefore, suppose if we calculated this value and this was equal to, let us say, 2 by 5, when 2 by 5 is over here, and if we draw a horizontal line like this, then it meets the graph over here, and therefore, this is the unique value. So, this value is cos inverse of 2 by 5. So, this is the unique value of the angle A, such that cos of A is 2 by 5. So, this uniqueness is just because of the fact that in this interval the cosine function is monotonically decreasing. It's basically because of the fact that in this interval the cosine function is a monotonic function. And therefore, from here in this case it is easy to find out the angles A, B and C. Angle A is cos inverse of B square plus E square minus A square by 2B C, and similarly we can find the other two angles also. So, B will be cos inverse of this value, angle C will be cos inverse of this value. Naturally, the next case is when all three angles are known. Now, in this case, if all three angles are known, one cannot uniquely say what are the three lengths of the triangle, and that is very easy to see. Suppose it is only said to us that angle B is 90 degrees, angle A and angle C are 45 degrees. So, essentially we have a right angle triangle like this. So, we could construct infinitely many triangles like this, and it is very easy. Basically what we do is we have 90 degrees at B, and then we construct a line, a vertically straight line like this of some length 2 centimeter. We construct another line at angle 90 degrees to this vertical line, and that is also 2 centimeters. Let this point be A and this point be equal to C, and then we join A and C. Naturally, because this and this side are equal, these two angles will be equal and they will be equal to 45 degrees. So, this triangle is satisfying these three conditions. Now, if instead of 2 centimeter, if we had drawn another bigger triangle where like this, where again we have 90 degrees at B, but now let us say this is 8 centimeter and this is also 8 centimeter, and then we similarly join A prime to C prime. So, even this triangle is going to satisfy these conditions, right. In fact, any triangle whose length AB and whose length BC are equal, and we have a right angle at angle B, any such triangle is going to satisfy this condition, irrespective of whatever is the actual value of the length. And hence, there are infinitely many triangles which can satisfy this condition. And therefore, if all the three angles are known, then one cannot find out the triangle uniquely. So, in general, except the case of the case where we know only the three angles, apart from this case, for any other case where we know 3 out of the 6 elements, the remaining 3 elements can be found out uniquely, except one more other case that we will discuss in the next few slides. So, one of course is the case where we know the 3 angles, and then there are of course many other possibilities that we will discuss one by one, where we know exactly 3 out of the 6 elements, and then we will show that it is possible to uniquely determine the remaining 3 unknown elements based on the knowledge of the given 3 elements. So, this process where we find out the remaining 3 elements, right, which are initially unknown from the knowledge of the given 3 elements. So, this process is known as solution of a triangle, so which was the title of this lecture. Another case is when, let us say, 2 angles are given and one of the sides is known. So, it is a case like this. So, let us say we know the length of this side, we know this angle A and this angle B is also known, okay. But then we do not know the other 3, elements which are, so we do not know the length of this side, we do not know the length of this side, and we also do not know angle C. This is not given. So, in solving this triangle, our attempt is to use the known values which are tick marked and use all the knowledge about the properties of triangles that we have studied in the last in the previous 8 lectures. So, using all that knowledge, the goal will then be to find these unknown 3 values. In this particular case, because these 2 angles are known and we know that the sum of all the angles of a triangle is 180 degrees. Therefore, finding angle C is easy. It is equal to 180 degree minus the sum of the other known angles. So, then I will convert this from green to blue. Okay, so, it becomes blue, this is known now, tick mark. So, we have ticked C now. So, the only remaining 2 unknown are the lengths of this side and this side. So, to know these lengths is not very difficult, because if we remember from the sine law, which is one of the properties of the triangles, from the sine law we have A upon sine A equals B upon sine B equals C upon sine C, right, and this is true for any triangle that we can construct. Now, here from this we see that we know A, we also know angle A, therefore, this ratio is known to us, and therefore, finding B and C should be now easy, because we also know the value of angles B and C. So, from here we have B equal to A by sine A into sine of B, and therefore, B is also known now, and similarly from here we have C equal to A by sine A into sine C, and therefore, the length of this side is also known now, and hence we have found the remaining 3 unknowns also, and this completes the solution of this triangle for this case. Another example is where the length of 2 sides is known and also the angle included by them. So, suppose that this is triangle ABC and we know this length C is known, this length B is known. So, these two lengths are known and the angle included between these two sides is this angle A, which is also known, and what is not known is this side is not known and these two angles are also not known. So, in this case our job is to find these three unknowns given the value of these two, the lengths of these two sides and the measure of this angle which is included between these two sides. So, in this, for this case we will use the cosine formula at angle A. If we remember the cosine law from one of the previous lectures, then we know that cosine of A is equal to B square plus C square minus A square upon 2 BC. And therefore, from here we can say that because we are interested in finding A, and there is only one term here which has A, which is A square. So, if we see in this equation, this angle A is known to us and B and C are also known. So, therefore, it looks like we can find the value of A. So, if we do some manipulation, we will see that A square is equal to B square plus C square minus 2 BC cos A, and therefore, A is equal to the positive square root of B square plus C square minus 2 BC cos A. So, once we know A, since we already know B and C, now we know all the three sides, and once we know the three sides, finding these two angles is again easy. So, we can go back to the first case where we discussed finding the three angles when the three sides are known. We again just have to use the cosine formula for angle B and angle C over here, and then B will be simply cos inverse of this value and C will be cos inverse of this value. So, now the only case that is left now is when we, in the previous case we saw that two sides are given and an angle is given, and this angle is the one which is included by these two sides. What if we know two sides, but instead of knowing the angle included between them, we know one of these two angles? So, that case is precisely this case 4, where we know this length C, we know this length B, and let us say that we know this angle B. So, this is known to us. However, angle A, angle C and the length of this side which is A is not known. And now we would like to see if how we can find these unknowns. So, we can again start since we know the length of this side B and we also know the angle B which is opposite to B. We therefore know the ratio B by sin B. So, if we recollect the sine law, we have A by sin A equals B by sin B equals C by sin C. Since the length of this side which is B and this angle B are known, the value of this ratio is known to us. Now, we also know this length C. Now, since this and this are equal, we know this length C, we know this ratio. It should therefore be possible to find the value of this angle C. From here we can write sine of C equals B by sin B from here we can write that sine of C equals C sin B upon B. Now, because this C, B and the angle B are known, we know the value of sine of C. But if this value is greater than 1, so suppose if it so happens that the parameters which are given to us, which is C, B and this angle B, when we put them in this equation, if we see that this value is greater than 1. So, if this is computed to be greater than 1, then definitely that is an impossible scenario, because sine of any angle can never be greater than 1, right. And therefore, in this case we have no solution. Now, if instead of being greater than 1, what if this is equal to 1? Else, if sine of angle C, which we have calculated to be C times sine angle B upon B. So, we are given C, B and this angle B, and if we compute this value and find out that this is equal to 1, that means sine C is 1, and in this case the only possibility is that C has to be equal to 90 degrees. And once the value of C is known, since angle B is known, we can find angle A. So, once this is known, we have angle A equal to 180 degrees minus C plus B, and C is pi by 2. So, A is equal to pi minus pi by 2 plus B, which is equal to minus B. And now that all the three angles are known, it is very easy to find the value of the remaining side A, because we have A by sine A equal to B by sine B, and therefore, from here A is equal to B by sine B times sine of A, but A is this value. So, sine of pi by 2 minus B, which is B into cos B by sine B is equal to B times cotangent of angle B. So, this is the value of the length of this side of length A. However, the third case is when this value is less than 1. So, we will take that case in the next slide. Else, so by else we mean if sin C, which is C sin B by B, if it happens to be less than 1. Now, from the graph of the sin x function which we are plotting here, now this particular value of sin C is between 0 and 1. So, let us say that this is our value here. So, this is C sin B by B, but corresponding to this value there are two possible solutions of C. So, either C is equal to sin inverse of C sin B by B, or the other solution is that C is equal to pi minus sin inverse of C sin B by B. So, in this case, for this case there is a little bit of an ambiguity whether we take the angle C to be this value or this value. So, here we have to see the value of angle B. So, in this, for this scenario where this value is less than 1, we have two further cases, sub cases. So, the two sub cases are if B is obtuse, and the other case is if B is acute. So, if B is obtuse, then clearly since B is obtuse, if the length of the side C, the side of length C, if C is greater than B, which we can check because these two values are given to us. So, if C is greater than B, then this clearly implies that angle C must be greater than angle B. So, this implies that, so this case, if this happens, then it implies that angle C is greater than angle B, but angle B is already obtuse. And if this is the case, then C also has to be obtuse because B is already obtuse. But we know that two angles in a triangle cannot be obtuse, and therefore, this if this is given to us, if the value of C and B given to us satisfy this condition, then no triangle is possible. That is, no solution. Else, so else means that, so this means that C is less than equal to B. So now if C is less than equal to B, it means that angle C, so this implies that angle C must be less than equal to angle B, and angle B is obtuse, and angle C is less than equal to angle B. Since angle B is obtuse, out of these two possibilities, this obtuse value of C is not a valid possibility, because we cannot have two obtuse angles in a triangle, and therefore, the only possibility of C is this value, because this value is acute and it satisfies this condition for this else case. And therefore, for this else case, if the given C is less than equal to the given value of B, then the angle C is equal to sine inverse of C sin B by B. That ends the case for where B is obtuse. The other case is else if B is acute, which we will take in the next slide. So, let us take the else case on this slide. So, the else case is when we are given a B angle which is acute. Now, because B is acute, then there are two possible values of C. C could be either sine inverse of C sin B by B, or it could also be, or the other value is pi minus this value. This is an acute angle and this is an obtuse angle. However, in this case, if C is less than equal to B, then it is clear that the angle C must be less than angle B, because if this side is, if a side is less than another side, then the angle opposite to that side is less than the angle opposite to the other side. So, C less than equal to B implies that the angle C is less than equal to the angle B. The angle B is already given as acute in this scenario, and because the angle C has to be less than angle B, angle C has to be also acute, and therefore, the only possibility out of these two is that C is equal to the acute angle, which is sine inverse of C sin B upon B. Else, what if C is greater than B? Now, this is the case where we will have some ambiguity, because if this side of length C is greater than the side of length B, then this implies that angle C is greater than angle B. Now, since B is acute, both these values are possible. Definitely this value is possible, because in this case, because if you see this basically implies that C has to be greater than angle B, and B is acute. So, therefore, this definitely is a possibility because angle B is acute, and therefore, this obtuse angle is definitely one value which the angle C can take. So, then we have that C could be either this value or it could be this particular value. So, either of these two values. So, C either so we could have either C equal to or C equal to so in this case where we are given an angle B which is acute, and if the side of length C is greater than the side of length B, then the angle C can take two different values. So, basically then this is the only case where given. So, let us characterize this ambiguous, let us try to understand this ambiguous case. So, in this ambiguous case, this is what we have. We have a triangle ABC where this side and this side, the length of these two sides is known and this angle is also known, and it is further given that B is acute and this length C is strictly greater than this length B. So, in this case, for this scenario, there are two triangles which will satisfy these conditions. So, then there is no unique triangle, but that is only for this case. And we can also take up a little example to illustrate this. So, let us take a little example to understand this ambiguous case a little better. So, suppose that we are given the length of in a triangle ABC, we are given C equal to 10 times root 3, B equal to 10 units, and let us say angle B is equal to 30 degrees or pi by 6, which of course is acute. And for this case we are asked to solve the triangle or find the triangle ABC, because we are only given three things, 3 of the 6 elements, and we have to find the remaining 3 elements. Of course, if we apply the sine law, then we have B by sine B is C by sine C, but B by sine B is 10 by sine pi by 6. Sine pi by 6 is half. So, this is equal to 20. So, from here we know that sine of C is C by 20. The length C is given to us, it is 10 root 3. Therefore, this is equal to 10 root 3 by 20, which is equal to root 3 by 2. But then there are, so we know that from the sine law and these given elements, we know that sine of angle C is root 3 by 2, and because C lies between 0 and 180, there are two possibilities. C is either equal to 60 degrees or it is equal to 120 degrees, but which one of these two we take? Now, we are given that B is equal to pi by 6. So, it is basically an acute angle. Further, we know that C is greater than B, which implies that angle C is greater than angle B. Now, there are two values of C which we saw from the previous slide are possible. So, the two values of C are pi by 3 and 2 pi by 3, but the question is, can we take these two values? In this case, since B is pi by 6 and the angle C must satisfy this condition, what we see is that both these values are greater than pi by 6, and therefore, this condition is satisfied for both these values, and hence both these values are valid, both these possibilities are valid, and therefore, we get two triangles. So, triangle number 1 will be where C is 10 root 3, B is 10, angle B is pi by 6, angle C is pi by 3, and of course, from these two we get A is equal to pi by 2, and then of course, the remaining side small a can be found out from the sine law, because A by sine A is equal to B by sine B, which is 20, and A is pi by 2, sine pi by 2 is 1, and therefore, A is of length 20. So, this is one of the triangles which we get if we take angle C equal to the acute angle possibility, which is pi by 3. The other case is valid case is when we take angle C to be 2 pi by 3. So, we take angle C to be 2 pi by 3, and therefore, angle A is, so this is 120. So, angle A will be equal to pi by 6, and then we have, because A by sine A is 20, we will get A equal to sine of pi by 6 is half. So, we will get A equal to also equal to 10. So, both these triangles are valid triangles, and one can also visualize this geometrically. It is not very tough to do so. With that, we come to an end to this lecture. So, in this lecture, we saw how using the properties of the triangles that we learnt in the previous 8 lectures were used to solve a given triangle, where if we are given only 3 of the 6 elements, then using the properties of the triangle, we were able to find the values of the remaining 3 elements, except of course, the case where we are only given the 3 angles of a triangle, in which case there are infinitely many triangles which will also have those 3 angles. And the other case was case 4, which we just now discussed, where in one of the sub cases of case 4, we saw that it is possible to have 2 triangles have the solution to that case. Thank you.